Okay, today we're going to get into 8.4. So we are at this point going to be 4 sections through our 5-section unit. And we're going to be able to evaluate inverse trig functions. So inverse trig functions are what we want to use when we're solving for the angle. Your homework assignment is the 8.4 worksheet. Let's go ahead and do some kind of warm-up problems here. For my first 4 questions, or A, B, C, and D, I'm going to be using the unit circle. So if you have your unit circle out, have it right beside you as you kind of work through some of these problems, because the question asks to name the reference angle and then also to find the value of the actual trig identity here. So we want the sine of 30 degrees. So in this case, my reference angle is really just 30 degrees, right? My reference angle is the same because remember, a reference angle is always between 0 and 90, and it's our distance to the x-axis. So our reference angle is 30 degrees. I then look at my unit circle and I say, okay, here's 30 degrees. The sine of 30 degrees, well, the x-coordinate is cosine and the y-coordinate is sine, so the sine of 30 degrees is 1/2. I then look at my next question, which is cosine of 2 pi over 3. So I find 2 pi over 3 on my unit circle, here it is, and I try to figure out, okay, how far away am I from the x-axis? Well, in this case, right, my distance to the x-axis being pi, or 3 pi over 3, right? If I'm at 2 pi over 3, then I am pi over 3 away from my units, or from the x-axis. So that's my reference angle. Then, since I need to find the cosine, right, I look to 2 pi over 3, and the x-coordinate is going to be my cosine value, so it's negative 1/2. Okay, let me go ahead and move my unit circle over here so that we can kind of use it. Let me clear my annotations as well. So then let's look at the next one. 7 pi over 4. Okay, so here's 7 pi over 4, and I want to know, first off, what's my reference angle? So 7 pi over 4 is from here up, right? And right here, I'm at 2 pi, 0 degrees, or 2 pi, whichever one you want to think of it. Or, in terms of fourths, I can maybe think of it as 8 pi over 4. So I am pi over 4. I'm 1/4 of a pi away from the x-axis. So that's my unit circle. Now, since I want the sine, right, I look to 7 pi over 4, and I say, okay, I need the y-coordinate. It's negative square root of 2 over 2. Last but not least, we have 7 pi over 6. So let me go ahead and find 7 pi over 6. Here I am. Now I am 1/6 of a pi, or pi over 6, away from my x-axis, so that's my reference angle. And since I want the cosine, I look to the x-coordinate, and it's negative square root of 3 over 2. So that's kind of how we use our unit circle, right? I kind of promised you that that was going to be our reference, our guide, and it is extremely helpful as we learn these things. Let me go ahead and delete that out of there. Now, why don't we go ahead and talk about, well, what do we do if something's not on our unit circle? What do I do if I need to use my calculator? So this question is asking for the decimal approximation. So up here, right, they ask for the exact value. That's why we had radicals in our answer. Down here, I'm going to let us just find the decimal approximation, and we're going to round to the nearest hundredth. So we're going to need our calculators. So our first one, and this should be labeled. I should have a degree symbol there. Without a degree symbol there, it's kind of hard to necessarily know if I'm in radians or degrees. So let's say we're trying to find the tangent of 2.6 degrees. So I'm going to pull up my calculator. And I'm going to make sure, first and foremost, since the question is in degrees, right, I want to make sure my calculator is in degree mode. So I go to mode, come down, make sure that degree is highlighted on my calculator, clear out of here, and I just go tangent of 2.6. And I get 0.045. So I'm going to go ahead and round that to the nearest hundredth. So I get 0.05. The next one, I want the cosine of negative 34.2 degrees. So I still want to stay in degrees, so I don't need to change my mode. Enter. and I get 0.827, so we'll round that to 0.83. And then our last one, this one is in radians, okay? So I'm going to need to go back to my calculator and change it to radians before I go ahead and type this in. So I go to Mode, come down, highlight radian, clear out of this, and I type in sine. Now here's where we're going to actually use that pi symbol. So it's second caret to get pi, so 3 pi divided by 7, enter, and I get 0.974. So I'm going to have 0.97. So that's how you use your calculator and kind of go back and forth between radian and degree mode. Moving on, so the inverse of sine. So what does that really mean? So the first question says, well, what makes the inverse of a function itself? So if we remember from Unit 3, which I know a long time ago, but in Unit 3 we talked about what a function is. So if we know a function exists and we want to make sure that an inverse of that function also exists, we need to make sure that every input has exactly one output. Right? If I put in the number 2, I want to make sure I always get out the number 1. If these 2 points, 2, 1, and 2, 3, exist on a function, well then that's not true. I don't know if I put in 2, am I going to get out 1 or am I going to get out 3? So this would not be a function and it would not have an inverse. So when we talk about, okay, we're going to use these inverse functions of sine and cosine, before we were finding the sine or cosine or tangent of an angle, now I'm going to give you the value of sine, cosine, or tangent, and you have to tell me what angle that applies to. So there's a couple different ways it can be written. Sometimes it's written like this, and for the majority, this is how I see it written. It's how your calculator has it. So it's second sine or second cosine, second tangent. So for the most part, we see inverse sine with kind of this mentality. Because you remember we had our function and then the inverse of our function, we had that little -1 there. This means the exact same thing, right? This is the inverse of sine. Sometimes we refer to it as arc sine or arc cosine or arc tangent. So we just have to know that both of those things mean the same thing. You know, just mathematicians trying to make it a little bit more complicated. So let's talk about restrictions, right? Because if you look at your unit circle, let me pull up a unit circle actually. So if I look at my unit circle here, when I look at it, I think to myself, okay, if I want to figure out, okay, what is the angle that has a cosine of 1/2? So I look to my unit circle and I say, okay, here's 1/2. So it must be 60 degrees, right? Well, the problem is, what about down here? 300 degrees also has a cosine of 1/2. So how do you know which angle you're referring to? How do you know which one is going to be returned by the calculator? So because of our repetitions that we see throughout our unit circle, we have to set up restrictions. We have to say, okay, which quadrants are we going to be referring to? So when we talk about sine, we want to make sure, well, any of these actually, we want to make sure we pick up a positive and a negative. So I think about, right, our all students take classes. In this quadrant here, right, everything is positive. In this quadrant here, sine is positive. So if I included these two quadrants, I would only get the positive sine values. Tangent down here is positive, so sine is negative down here, but sine is also negative here. So which one do I want to use? Well, because we're going to need it to be fluid, and in our last section we're going to be graphing these, so hopefully it will, the reason for the restrictions will hopefully make a little bit more sense as we get through that last section. I want to include these two quadrants, because in this quadrant I get positive sine, and in this quadrant I'm going to get negative sine. So my restrictions for the sine values is going to be between -90 and positive 90 degrees. Or if you want to think of it in radians, -pi/2 to pi/2 radians. So that is where we're going to restrict sine. Now let's talk about cosine. Well, cosine is positive here, and cosine is negative here. So this one's a little bit easier. We're going to include these two quadrants, because by including these two quadrants, I pick up both the positives and the negatives. So here, we're going to go from 0 up to 180 degrees. Make sure I put my degree symbols in there. Or if you want to think of it in radians, 0 up to pi. And then our last one for tangent, this one might seem a little bit tricky, right? We've got our positive tangent here, but then we've got negative here or negative here. So which one do I use? Well, we use this one down here. And again, once we graph these, hopefully it will become clear why those are the ones that we're using. So just like sine, we're going to go from negative 90 degrees all the way up to positive 90, or if we think about it in radians, negative pi over 2 to positive pi over 2. Some useful inequalities, we didn't talk about these last class, but they were at the bottom of the last section and they're here included on this section. When you're trying to find the cosine of an angle or the sine of an angle, it's always a number between -1 and 1. So if I ask you, hey, I have an angle and the sine of that angle is 46, I can tell you you're lying because there's no angle in existence that can have a sine value that's greater than 1. So our sine and our cosine values are always going to be go between -1 and 1. Now that is not the case for tangent. Tangent's a little bit silly, but we can use those types of restrictions to say, okay, this is a trick question. Now if you do it on your calculator, you're going to get an error. So don't worry too much. You will be reminded of that. So how do I do it, right? How do I evaluate this expression? I recommend using that reference angle again, trying to figure out kind of where you are on your quadrants here, and then think of it like your bow tie, right? There we go, there's my bow tie. Right, those are our reference angles. These are the angles in here that we want to consider. And then it's going to help you to think, okay, which quadrant should I be in for either cosine or sine? So let's do some examples. So the sine of -1/2, okay? So I'm trying to figure out an angle, right? It must be between -90 degrees up to +90 degrees because we're talking about sine. And yeah, that's really all we have to do. So let's look at our unit circle. Right here, I'm going to look at sine, and I'm going to look in these two quadrants here, and I want to see, okay, what angle has a sine of -1/2? Well, it's down here, right? It's down here. Unfortunately, though, it's 330 degrees on my unit circle. 330 degrees is not between -90 and +90. So I need to convert 330 degrees to a number between -90 and +90. So we would think at first, oh, it must be 330 degrees. But this doesn't meet our restriction, right? We wanted our restrictions to be fluid, to be between these two numbers. So I have to find a coterminal angle with 330 degrees. So if we remember how to find coterminal angles, I simply have to subtract, either add or subtract. In this case, we're going to want to subtract, so I get -30 degrees. So that is my answer to this. Let me make sure I highlight that -2. It says up here to do it in both radians and degrees, so let's make sure we also simplify this into radians. It's -pi/6, right? If I want to convert this to radians, I just go ahead and multiply by pi/180, and I simplify my fraction down. So these are my two answers, -30 degrees and -pi/6. Let's look at our next one. Cosine of -√3/2. So our restrictions on cosine are going to be between 0 and 180 degrees. These ones are a little bit easier. So I'm going to look at my unit circle. I'm going to say, okay, on these two quadrants, because quadrant 1 and quadrant 2, that's where cosine is going to be restricted to. I want the cosine to be -√3/2. Well, here it is over here. It's 150 degrees, or 5pi/6. So that's kind of nice and easy. I get 150 degrees or 5 pi over 6. Last but not least, I've got tangent. So I've got tangent of 1. So I need to, again, I'm restricted between negative 90 and positive 90 degrees. And for tangent, when I think about tangent, right, I think about, okay, tangent is sine divided by cosine. So if I want to get a 1 for my tangent, I need to find an angle that has both the same sine and the same cosine, right? Because if my numerator and denominator have the same numbers, then they just cancel out and it's 1. So let's go ahead and look at our unit circle and figure out, okay, between which angle has the same sine and cosine. Well, it's right here. It's 45 degrees. So 45 degrees or pi over 4. Last but not least, we have this inverse sine of 3. So I want to find an angle that has a sine of 3. But we just talked about the restrictions, right? I'm not allowed to have a sine that is greater than 1, right? It stops at 1. So therefore, this does not exist. And if you try to put it in your calculator, you're going to get an error message. Now let's do some problems that have us using our calculator, because I know we want to make sure that we know how to do these. So we're going to calculate the inverse sine of 0.8. So 0.8, right, it's less than 1, so I'm good there. I can actually plug that into my calculator. Right now, I believe my calculator is in radian mode. Let's just double check here. It wants us to find both, so I just need to make sure what mode I'm in as we go. Yep, I'm in radian mode right now. So I do second sine. Oh, I must not have hit the second button. Second sine, and then I see that little inverse function, right? That tells me I'm doing the right thing. And I want to plug in 0.8. So what angle has a sine of 0.8? Well, in radians, it's 0.93. Now, if I change my mode to degree, clear out of here, I'll put the same thing in again. Second sine, 0.8. So what angle in degrees? Oh, 53.13 degrees. So let's go ahead and fill that out here. So I have 53.13 degrees, or 0.93 radians. As simple as that. Let's try the next one. Inverse cosine of negative 0.473. So let's find the degrees one first, since we're in degrees right now. So second cosine, negative 0.473, enter. And I get 118.23 degrees. Now let's change our mode. Second cosine, negative 0.473. And I get 2.06. So let's go ahead and fill those out. 118.23 degrees, or 2.06 radians. Right, let's move on to a couple of word problems. Now, since we're going to be doing word problems, I would encourage you at this point to switch back to degree mode, because I'll tell you right now, right, if a question is asked and they want to know what is the angle, well, most people don't think in radians. So we want to make sure we have our answer in degrees. An airplane rises vertically 2,000 feet over a horizontal distance of 2 miles. What is the angle of elevation of the airplane's path? Okay, so over the course of 2 miles, we're going to rise 2,000 feet. And in here, right, we see that 2 miles, I don't want to write 2 miles, right, because I want all of my units to be in the same thing. So if I want to figure out how many feet are in 2 miles, I'm going to be doing 2 times 5,280, so I can get the foot amount. So here's my horizontal distance. Draw a straight line, right, my horizontal distance. So here's the 2 miles, so that's going to be 10,560 feet. And I want to know the angle of elevation. I want to know this angle right here. So here's my angle, right? I have opposite and I have adjacent. So what trig function uses opposite and adjacent? Tangent. So I have the tangent of theta is equal to 2,000 over 10,560. I don't have to simplify anything, right? At this point, because I know I want to find the angle itself, I'm going to find the inverse calculation of both of this. So those two cancel out here, and I get that theta is equal to the arctan, or inverse tangent, of 2,000 over 10,560. So I'm going to go ahead and put exactly that into the calculator. So I go second tangent, 2,000, make sure you're in degree mode, divided by 10,560. And I get about 10.7 degrees. 10.7 degrees. So that is our answer right there. Let's look at our next question. Our last one here. If a building that is 52 feet tall, okay, here's our building. It's 52 feet. Casts a shadow that is 23 feet. So we've got a shadow right here on the ground. That's 23 feet. What is the angle of elevation to the sun? My theta. So this is also a tangent one. So I get the tangent of theta, right, is opposite over adjacent, 52 over 23. So that tells me theta is equal to inverse tangent, or arctangent, of 52 over 23. Come back to my calculator. And I get out about 66.1 degrees. So that sums up 8.4, how to find angle measures instead of the actual trig function, using those trig ratios to back out and find the angle itself. So go ahead and do the 8.4 worksheet.